Welcome to page 3 of linear equations. Let's review a few things about linear equations. Remember, when it's a non-proportional linear equation, our equation tends to look like this. M times x plus or minus b equals y. We know that this particular equation, when we graph it, will not pass through the origin 0, 0, but it will be straight. Let's read. Complete the table of values for the equation 2 times x minus 1 equals y. Use the table of values, graph the line of the equation. Well, let's take a look at our table of values. Our x-coordinates have been chosen for us. Sometimes you get to pick your own x-coordinates, but in this case, our x values or x-coordinates are 1, 2, 3, and I'm going to add a fourth value of 0. And our y-coordinates, well, we have to determine the y-coordinates using the equation. The equation states, please record these notes on your paper, 2 times x, we're going to double every x and take away 1, and that will give us our y value. And that's what we're in search of. What are our y values? So, let's take our first x value and substitute into the equation. Here we go. 2 times, let's take the number 1. 2 times 1, take away 1, equals y. Well, 2 times 1 is simply 2. And when we take away 1, we get a y value of 1. So our first ordered pair, and we can record that right here, is 1, 1, 1, 1. Let's do another one. Let's take the same equation and substitute a 2 in for x. 2 times 2, take away 1, equals y. Well, 2 times 2 is 4. But we need to take away 1. We get a y value of 3. We write that in the table, and we know we have to plot 2, 3. Our next value given in the table is 3. Let's substitute that into the equation. 2 times 3, take away 1. Well, 2 times 3 is 6. Take away 1. That gives us a y value of 5. So our final point that we're going to plot is 3, 5. Hang on to the 0 for a little bit. We'll look at that later. Before we plot these 3 points, let's take a look at our delta y to see how our y values are changing, and our delta x values to see how our x values are changing. If you look at your y values, we are obviously increasing each and every time by 2. And if you look at your x values, you can see each and every time we are increasing by 1. So, our delta y over our delta x is a 2 to 1 ratio. Remember, the y controls your up and down movement, and this happens to be a positive 2, so we're going to go up 2. And that 1, which is a positive 1, that controls your sideways movement. Let's get ready to graph our points. Here's our x-axis and here's our y-axis. We always consider our start point 0, 0. However, this time we only need to go over 1, up 1, and that is our first point, 1, 1. Our next point is over 2, up 3. That is the point 2, 3. And our last point is over 3, up 5. You can see that a trend or a pattern is developing. Our points are climbing at a steady pace. In fact, we are always going up 2 over 1. Up 2, 2 blocks, over 1. Up 2, over 1. And we know if this continues, our next point would be up 2, over 1, make a nice solid dot. And again, up 2, over 1, make a nice solid dot. It almost looks like a staircase. Let's put our pencil point on our very first point, 1, 1, and let's continue this step process working backwards. Go over 1, down 2, and make a nice solid dot. Over 1, down 2, make a nice solid dot. Over 1, down 2, and continue this until you run out of graph. All of these points that you've marked are solutions to this particular equation. Any one of these would be a solution. Now grab a ruler and connect up your dots. Make a nice solid line all the way through the points and mark each end of the line with arrowheads because the line continues on forever and ever. We've just run out of graph paper. And the final piece, please label the line you graphed with the equation that it represents. Before we conclude, let's talk about two important things. The slope, which we can label down here over delta y and delta x, and the y-intercept, which we really haven't discussed all that much. But let's start with the y-intercept. If you look at your y-axis running vertically, the y-intercept for this particular equation is this point right here at -1. It is the location where your line, the purple line in this case, intersects the y-axis. That's a significant point, and as an ordered pair, you would represent that as over 0 down -1. This is the point, the ordered pair, where the y-intercept is located, at -1. So that's the first new vocabulary. It is called y-intercept. And we've spoken about slope before, but let me just remind you that your delta y over delta x ratio, that represents the slope. Sometimes you may have heard people refer to it as the rise over the run. Please record these notes. And that's where this little stair step comes in. As you go up 2, that is called the rise or the delta x, the change in x. And we see it right here on the table. As you move sideways, in this case to the right, you run 1 block. That is the run value, or your delta x. And we see that right here on the table. So, a new vocabulary word today. Y-intercept, and again, it's where the line intersects the y-axis. And then again, don't forget about slope, sometimes referred to as rise over run, or delta y over delta x, change in y over change in x. This concludes page 3.